Hi friends, welcome to SDC 2021. Good morning, good afternoon, good evening, wherever you are. Today we'll be discussing in this session about data management going beyond storage boxes, mainly exploring the trends in cloud native data management, how it is shaping up, and how storage vendors are thinking about new solutions within the storage and outside the storage. Myself, Sanil Kumar D. I'm working as a chief architect in Huawei Technologies and part of Soda Foundation as a technical oversight committee and heading the engineering part of it. Let's get started. This looks very obvious that everything is connected anywhere. So we are in a connected world. So when you say anywhere, there are different domains, like predominantly we call it as edge, on-premise, or cloud. So wherever the data sources and wherever the data destination, wherever it is, our requirement is to manage the data from anywhere. We'll see little more details onto this. So like I mentioned, you have edge, core, and cloud. And at the same time, from the storage space, you have different storage types like file, block, and object. And based on the use cases, we use specific storage types. On the right hand side, you can see platforms. When you see platforms, it can be Kubernetes, Open VMware, OpenStack, and so on and so forth. The traditional platforms or newer platforms, and the applications, the workloads have different kind of requirements today. There are different kind of applications and use cases. So what we want unified, whether it is edge, core, cloud, doesn't matter. I have multiple clusters, multiple regions, it doesn't matter. We want a unified data management provision, including the visualizations, monitoring, and so on and so forth. And it has to be globally managed. So it should be unified and we are able to manage globally across edge, core, cloud, and whatever may be the storage type and whatever may be the platform, applications, and use cases. So this is our demand or requirement. So we'll see what's the current trend and where we are heading to. So we have been hearing about storage as a service. Now we started hearing as container storage as a service. How much is this container movement is important? Okay, we'll see some of the reports and information, whether it can guide us, saying that, yeah, this is some important direction. So on the left hand side, you can see SODA data storage and survey. What we have done is that we have done a data and storage survey with vendors, users, and different integrators. So predominantly what we see is that it's the momentum is towards container based environment, though the market share is not that predominant today, but the growth is high. And there is a rapid transition happening from VMs to containers. This is not with respect to storage, but it is just about the compute or the platform side. And Kubernetes becoming a top kind of a platform which people want to use and they want to move towards it. So especially Kubernetes Cloud, hybrid Kubernetes on-premise, and etc. And more importantly, container storage for real use cases deployment is a fact. It's not a notion today. So this is from our survey. And at the same time, if you see, there are some industry survey. I have given the links in the notes. There are reports saying that application container market growth is around 26+%. This number, various reports says different numbers, but it's prominent. It's 25 to 30% of growth is happening. That's quite significant. And container as a service is also growing as 35%. If you see, most of the applications are becoming or service model, microservice model, and you get everything as a service. And the real installed base of container instances, that growth is predominant. I mean, very, very high. It's around 60+%. in 19 to 23, 2019 to 23. And like I mentioned earlier, it is no more a notion. Container in production is a reality today. Okay. So what we get from all these indicators is that container-centric storage solutions will be important, because the container, if the container deployments are moving, of course, the container storage momentum has to be there. And hybrid cloud data management for especially data disaster recovery kind of use case is very important, because when you start moving to a new kind of a domain, let's say multi-cloud, the users will predominantly see a kinetic, start with backup recovery kind of model rather than critical applications. So DR is becoming something like a prominent use case. And we also see that container storage as a service as a prominent direction. So because of this, even this is indicated by some of the new products from the storage vendors and storage solution providers. So the trend is that with the storage boxes, the features for cloud native, or like snapshot across cloud or cloud native storage kind of stuff, people are trying to do research, and there are products. And outside the box features for data management and operation and management kind of thing, it's increasing. So there are a lot of open source projects, and even storage vendors are coming up with products where you have the stack supporting the data management outside the box. And another point is that third-party storage support is becoming more prominent, because people see that anyone can buy any storage and then deploy different clusters based on the use cases, cost, and etc. into different storages. That was one of the key problems, but that is becoming more liberal today of the technology, the different technologies. So the storage vendors also see this as important thing for their overall solutions business value. And of course, multi-cloud, like I mentioned. And more important point is that application aware data management. This is becoming prominent, that the overall end-to-end stack is more application aware, so that based on the use cases, be it AML, then probably your data management and the overall management of the data needs to be in a certain way, and it has to be optimized for it. Say, for example, big data or AML or edge kind of a scenario. So probably the type of data and the size of the data, all these things can be different. So it all depends on the application. So the solution should be more application aware. So there are some few examples I have given. There is no priority, just like that I put some examples. NetApp Astra, VMware Tanzu, and VMware Velero. Velero is kind of a data protection solution, open source solution. And Tanzu is also a predominantly open source overall solution. And Pure Storage Orchestrator. And there are many, okay, HP, IBM, there are different solutions. You can Google and find out solutions. Just I given some examples. So the key message is that it is not limited to the storage box features anymore. The features are even complementing from outside. And another key point is that everybody is striving to utilize best utilization of open source and own products to build the overall solution. And application aware data management and container storage push this trend, that how they can leverage the existing solutions, because it's not a bottom-up approach. So you need to utilize what is available from in the industry and the ecosystem. Okay, this is just to scare you that container landscape is quite big, and most of the storage vendors, integrators, or solution providers, cloud vendors, almost all organizations, top organizations, are one or the other way working in this. If you zoom and see, most of the companies will be there, the top companies in the container landscape in various domains. It can be application deployment, maybe orchestration, runtime, automation and configurations, and so forth. Every area, there are so many projects, open source projects, and ecosystem players are coming up to add to this landscape. So it is. So this also indicates, is another indicator that things are moving in this direction. So now we look into a little more details on container data management, what it is, what we call it as container data management, CSI, and so on and so forth, cloud native. So there are always, we have this confusion that what is cloud native storage, what is container storage, what is CSI, right? So cloud native storage, basically you can say is like a software defined storage which has got an API driven. It's completely API driven, and kind of it can auto provision and manage the solution. And of course, it is scalable, performant, and also secure. So security is one key point. Performance, sorry, and it has to be scalable, because most of the users, they want to start small, and then as the demand of their infrastructure requirements increases, they want to increase. So it has to be scalable based on their load, or the anticipated load. So that's the way things move. So cloud native storage gives kind of a guideline that it has to be API driven, it has to be secure, it has to be performant, it has to be scalable. So those kind of things, we can call it as cloud native. And one such thing is container storage. So container centric storage solutions are cloud native storage solutions and more. So basically, container storage is a cloud native solution, but cloud native storage, we can't say it is only container storage. Okay, that's a difference. And of course, in container storage, we have the declarative APIs, auto healing, and developer productivity, cost optimization, truly hybrid. Those, there are some additional good features with respect to container deployments. And now, what is CSI? Okay, container storage interface is actually a specification which provides you a certain interface definitions from a container orchestration engine. We will see the stack later. Container orchestration engine to talk to your storage. So it is a specification. Now it's not as even a software, it's actually a specification. Now you have to have CSI driver or plugin. That is a translation of the specification to software. Okay. Now, this, I have prepared this cloud native stack based on the cloud native landscape. So you have business applications, you have application platforms. It can be for database, streaming, messaging, various kind of use cases. You can have different applications, platforms, dedicated application platforms. On top of that, your real actual business applications will be running. And below, it is a container orchestration and management, because in a cloud native stack, this is a like a container orchestration engine. And management has to be there. So orchestration and scheduling is to be there. Service discovery, because most of the service, the features are as a service. It is provided as a service. And RPC, service proxy, API gateway, service mesh, all these things are elements on container orchestration and management. And then comes all these are running in container, then inside, then multiple containers, pod. I mean, in Kubernetes terms, pod is a collection of containers, and so on and so forth. So what one service can be multiple pods or a group of pods. That means that group of containers, you can say. And then all these things will run on runtime, right? So in runtime, there are predominantly three things. One is compute, the container runtime engine, it's like Docker and so on and so forth. Then container storage. So the container storage will be something like CSI or container storage specification defined APIs will help you to connect to the storage. And there can be container attached storage also. CAS is another option. And then container network, CNI. Okay, container network interface is CNI, and CSI is for storage, and then compute interfaces. So this is part of runtime. And then below you can have the host OS, and then all these things. On the right hand side and left hand side, you can see automation and configuration, container registry, because almost all the images are coming as an registry. You can have the image download and deploy it, I mean, seamlessly. And security and compliance and key management. Key management again is on security part. So let's focus on the container storage part, which will help us to connect the container orchestration engine to the storage boxes. Now we have seen a landscape of all the projects, the container projects, but I just zoom that part to see cloud native storage projects. So for the storage part, cloud native storage, there are so many projects coming up. This may be a limited diagram. There are so many other new projects into play. I mean, in the industry, be it open source and non-open source. Now, in the cloud native landscape, okay, Soda is already there. Soda Foundation is part of this because we work on an open data framework. We'll see in detail later. This, whichever is circled, are some of the projects like Zengo, OpenEBS, LinStore. These are some of the projects recently joined Soda Foundation as an ecosystem project. Why? Because the open source open data framework from Soda can co-work with these projects and build suitable solutions. Okay, so we are discussing with OpenEBS, LinStore, and Zengo, and see that how our Soda Foundation existing projects, the ODF projects, and these can work together to build open solutions which can solve some specific data management problems for containers. Okay, that mapping came later. Okay, so now we talk about open data framework, wherein there are many things like VM, bare metal applications, and so on and so forth. So we sit in between the open data framework, which can connect edge, core, and cloud. That's our dream and wish, the direction. And right now we have the on-premise and cloud solutions, and edge we have started some kind of a POC. Now, be it block file object, backup recovery, archive retention, security, data lifecycle management, hybrid and multi-cloud, edge data management, monitoring and analysis, all these things. Our idea is to provide an open data framework to have all these data management features as unified and global. That's the idea. So unified data and storage management with single open framework across cloud, core, and cloud. So this is a very high level diagram of Soda ODF open data framework. I'll not go through, read this text. Basically, some of the highlights is end-to-end. We want to give end-to-end. You can see top the platform and bottom the storages. The storage can be on-premise storage, cloud storage, or edge storage. It doesn't matter. And in between, we have components to connect these to provide a seamless data management for any platform and any application. That is where so that's why you can see a Soda plugin. So wherever the APIs are not supported, the Soda APIs are not supported, we can have a plugin model wherein you can connect any platform to any storage below. Where we have doc is where the storage driver get connected, and API and controller makes the API interface and the bookkeeping, the controller part. And multi-cloud is a separate project which handles multi-cloud data management. So the key point is it's open source. It's completely open source, and it connects data silos because we provide all the data management solutions within this framework, and it is scalable. So most of the design, then it's based on extensibility. And so we try to work with the partners and organizations. Around 30 organizations are part of Soda Foundation, and Soda Foundation is under Linux Foundation. So we have close to 30 plus organizations part of this, and we work on standardization and very positive and inclusive ecosystem. And also later on, we plan to come up with certain certifications on these compliance on these APIs or features. So Soda ODF runs in your cluster outside and agnostic to your storage box. Basically, the Soda ODF is completely outside your storage box. Okay, all the data management or data connectivity, what is provided, or even the storage monitoring or storage management provided by Soda ODF is completely outside your box, storage box. Okay, this is an example of use case which is given. Why? Because this, say, autonomous vehicle, when you consider, it has got edge, it has got on-premise, so it has got cloud. So this, if you can support this kind of a use case, probably, most of the use cases can be, addressed, right? So we should be able to deploy Soda in edge or on-premise or cloud and manage all the cloud and all this data, transitions across these domains. So this is again a repetition, whatever features we are talking about, and the data lifecycle management, migration, data protection, and so on and so forth. Okay, so this is something like a SODA CDM kind of a stack, what we are looking at. So you have application workloads and container orchestration engines like Kubernetes. And of course, we are talking more about the control plane. And in Kubernetes or this kind of a container orchestration engine, the control plane is mainly CSI. Of course, you have Flux, DVDI, and all these things, but prominently today, the CSI is kind of an accepted platform. Sorry, the specification to follow. So the green part is kind of a stack which we are talking about. This will be similar to any product stack which is trying to build a container data management solution. Okay. So you will have, of course, the global controller, global metadata management independently within the platform. And we have something called SODA CSI. We have a SODA CSI plugin which can support heterogeneous storage management. Okay, I'll talk about it a little later. And then we also have data management extensions. Okay, so our plan is to have separate extensions for different data management entities like data protection, observability, data mobility, and so on and so forth, to connect seamlessly with Kubernetes. So we will have an interface to the control plane definitions, and we also have connectivity with the Kubernetes API to manage the application-aware data management within the open data framework, which we call it as SODA CDM for container data management. Okay. So we are looking at unified CSI, heterogeneous ready. We already support heterogeneous to a great extent, even in Kubernetes and outside, even OpenStack also we support. And design for a container data management, especially we are looking at the key focus right now is data protection and data observability along with migration and hybrid data management. Like we support cloud, right? Cloud and on-premise to start with. And SODA CSI, what is the difference between the SODA CSI and vanilla CSI? So vanilla CSI, if you have, say, different storages in your deployment, you need to have multiple CSI, multiple management, things like that. If it is separate with different vendors, I mean, it's altogether different plugins. In SODA CSI, it is unified CSI for all. And we also support plug and play in the sense your existing CSI CSI driver or CSI plugin can be a plug and play with the SODA CSI without changing the code. Okay, so that's very easy. So you have this. We will see some more details on that the architecture. So that's very a good added advantage that the existing CSI drivers itself can be used. And of course, it is future ready to enhance these the common CSI to support observability, data protection, and so on and so forth. So that will really help. And some of these are some of the key features which we have already released in the last release. So the link I have given here. So you can go and try out and give us feedback. And you can also join this development process. I have given some links at the end, so you can join our Slack and community so that we can collaborate and work, because this is on the beginning stage and a lot of things to do. So we support CSI plug and play, multiple concurrent CSI drivers at the same time we can work. It works. And we also have a POC on data protection framework based on Rustic. It's an application aware data protection outside the box and outside the CSI, of course, because CSI doesn't support this feature today. And policy-based application consistent snapshot. These are some of the POCs which we have released. And our idea is to enhance the unified CSI and have data protection observability as some of the end-to-end features for CSI, Kubernetes, with or without CSI. Okay, because some features, as I mentioned in data protection, the storage SIG has been discussing about enhancing CSI to have data protection features and observability, also storage observability. We have a project called Delphin, complete storage monitoring, which we are thinking to migrate to Kubernetes environment. It's already microservice based, so it will be easy for us to migrate and provide storage level monitoring across different vendors, vendor agnostic and unified visualization. And we also have a exporters for Prometheus, Kafka, and even for third party. So this is something like a very high level design diagram for CDM data protection POC, wherein you can see that SODA CSI provisioner, it is our custom provisioner, CSI provisioner, and the request comes normally to the CSI, and then the metadata will be managed by our SODA metadata management. And then we have created a small module called SODA Syncer based on Rustic. And you can do on-premise data snapshot at file system level, and to write or take a backup snapshot to any of the clouds. So like S3 or Wasabi, Azure, and so on and so forth. So this is a high level diagram. This is at a POC level. So what we want to do is that we want to build based on further analysis. We want to create modules which are scalable and optimized and tunable to do application aware data management. Because when you say application protection in Kubernetes, there are different aspects: application protection, maybe namespace protection, or cluster level protections. So multi-cluster protections, all these complexities are there. And even for application protection, there are different use cases. It can be for cloning, this can be data cloning, and it can be for even migration. Other than this, backup and recovery, archival and retrieval in case of a legal, or you want an old version to be retrieved. So in application protection itself, there are different use cases, not just data backup and recovery. So we need to consider all these factors to build a proper end-to-end stack. And similarly, this is what we talk about SODA CDM CSI plug and play. So if you see on the left hand side is a typical CSI components, nothing different, no need to worry about too many boxes there, but it is a typical CSI deployment diagram, wherein the blue things are SODA attacher. It's default, it will be a Kubernetes default CSI attacher or provisioner or snapshotter. But what we have done is that we have, instead of that, we use SODA attacher, SODA provisioner, so that we can talk to our metadata management, right? So you see on the right hand side, this is plug and play, where a user request comes to the Kubernetes API server, and then it goes to SODA provisioner, and then there is an update happens between our metadata, so that we have all the provisioned storage metadata within us, so that we can manage very easily, unified, global, like that. Then the SODA provisioner will talk to the TP. TP is third-party controller. That is nothing but your CSI plugin. You can have NetApp Trident or EMC or any other, or SDK, or so on and so forth, where you have the CSI plugin. You can use the CSI plugin directly, and then the SODA CSI attacher has the connection with the metadata and attaches the volume. So this is very high level. In our GitHub, the detailed design, and you also can try out this today. In our last release, if you take, you can actually try out with LVM and other some of the supported drivers. And you can even try if you have storage boxes, because that is a major challenge for testing. So if you have the real storage boxes, you can take the corresponding CSI and just plug and play with our platform and test it. So it supports the heterogeneous out of the box. And this link, because of the time, I can't show the complete demo today, but you can go and watch this session where it's completely a demo, CDM features, container data management features of SODA Open Data Framework, which is just demonstrated based on the last release in our SODACon 2021. So you can watch this, and you can also connect us. And what is data management going forward? Like I mentioned, it will be mutually complementing solution standards between inbox features. Of course, inbox features will be increasing, and storage vendors will try to have that kind of an edge, of course. But the outside box equally strong, and it will grow, especially with the open source ecosystem. And storage as a service and container storage as a service is going to be the norm going forward. Cross-cluster, closed cloud, cross-domain is going to be key demands based on the application deployments today, what we are seeing. And storage vendors come up with out-of-box solutions for hybrid scenarios. In the sense, what they're trying to do is that they have the storage boxes and they have bundled all other components together, so that inside the box and outside the box, most of the application aware data management can be done outside, and the storage specific data management and data operations can be done within the storage optimized. Say for example, if you want to hardware accelerated kind of a migration or snapshot, so that can be done in the storage. Otherwise it can be done in outside, and equally strong. So that will be the style in which the probably we are expecting that the storage vendors will move that way. And cloud vendors are moving to enterprise. It's very obvious. I mean, AWS, EKS, anywhere, and all these kind of solutions are coming up that enterprise side. And at the same time, storage vendors, they need to move to cloud, and they have native solutions for their own storage. We can see NetApp, AWS, NetApp, different cloud, Google, and kind of stuff, which is natively they support as a storage as a solution service. So these are some of the indicators. Of course, technology is very dynamic, but this is kind of a definite. It is converging. All the reports, all the momentum, all the new products are converging. That data management is more happening and shaping outside the storage box than inside. And that's all for today. Thank you so much for listening. And these are some of the links. You can join our Slack, and you can go through our documentations. And please join us to build this kind of open source solution for container data management. Thank you so much.